Determine the direction in which a straight line should be drawn through the point having coordinates 1, 2, so that the point where it intersects the line x plus y equals to 4 is exactly square root of 2 over 3 units away from 1, 2. Okay, let us begin. So first, let's try to understand the problem graphically. So here we have, let's say, a line which is denoted by the letter L, and it is passing through the point A having coordinates 1, 2. Now we are going to consider another line x plus y equals to 4 such that it intersects the line at another point. Let's call it B. So the blue line is going to represent the line x plus y equals to 4, and let's say it intersects the line L at the point B, and let's say it has the coordinates x, y. Okay, now it's given here that the distance AB, that's equals to square root of 2 over 3 units. Now, using this information, we need to find out the direction in which the line L is pointing. That means, in other words, we need to find out this angle alpha. Okay, so this is the angle that the line L makes with the positive direction of x-axis. So in our problem, we need to find out the value of alpha. Okay, so here what we'll do is use the distance form of a line. So considering the line L, clearly this line is passing through 2 points. One is the point A with coordinates 1, 2, and the other is the point B with coordinates x, y. So when we apply the distance form of the line, we have to be careful here, since the coordinates of A, that means the x coordinate and the y coordinate, are greater than the x coordinate and y coordinate of B. So what we'll do, we'll consider 1 minus x divided by, we'll take cosine of that angle alpha. This is going to be equals to, now we take the difference of the y coordinate, so that will be 2 minus y divided by sine of the angle alpha, and this is going to be equals to the distance between the 2 points E and B, so that's given by square root of 2 over 3. So this is what we are going to have when we apply the distance form of the line. In other words, what we can do, we can rewrite the equation as, so we take 1 minus x over cosine of alpha and simply equate it to square root of 2 over 3. And we have 2 minus y divided by sine alpha, and that is going to be equals to square root of 2 over 3 as well. So here we can isolate x and y. So x is going to be equals to, we have 1 minus square root of 2 over 3 times cosine of angle alpha, and then y is going to be equals to 2 minus square root of 2 over 3 times sine of angle alpha. In other words, what we have done here is we have converted the coordinates of point B, which are x, y, into a parametric form. So here we can say that the coordinates of point B, which we initially considered to be x, y, so here we have successfully represented in the parametric form as 1 minus square root of 2 over 3 times cosine of alpha, and the y coordinate, that's 2 minus square root of 2 over 3 times sine of alpha. Fine. Now, as we can see here, the point B, clearly the point B is also going to lie on the line x plus y equals to 4. So here we can say that since the point B lie on the line x plus y equals to 4. In other words, we can say that the coordinates of the point B is going to satisfy the equation. So here what we can do, we can replace x with the x coordinate of point B. So we have 1 minus square root of 2 over 3 times cosine of angle alpha added to y. So y is going to get replaced with the y coordinate of point B. So that's 2 minus square root of 2 over 3 times sine of angle alpha. That's going to be equals to 4. Okay, fine. So let's further simplify. So here if we take negative square root of 2 over 3 as the common factor, so this is going to get multiplied to cosine of angle alpha plus sine of angle alpha. And on the right hand side, what we can do, we can transpose 1 plus 2 and subtract it from 4. That's going to leave us with 1. Okay, now further simplification is going to give us cosine of angle alpha added to sine of angle alpha. So that's going to be equals to negative square root of 3 over 2. Now let's do one thing. Let's square both sides. So squaring both sides gives us cosine squared alpha plus sine squared alpha added to 2 times cosine of the angle alpha times sine of the angle alpha. So this is going to be equals to 3 over 2, which means we have, now what is cosine squared alpha plus sine squared alpha? That's a identity, that's 1, so we have 1 added to, and 2 times cosine alpha times sine alpha, this is simply going to be sine of the angle 2 alpha. So here we have used the fact that 2 times sine of angle theta times cosine of angle theta, so that simply equals to sine 2 theta. So we'll use this fact and that simplifies the problem. So this is going to be equals to 3 over 2. Now let's transpose 1 to the right hand side and subtract from 3 over 2, and we are going to get sine of 2 alpha. This is going to be equals to 1/2. Okay, now when is sine of some angle equals to 1/2? So there are two possibilities. So we have sine 2 alpha, so this is going to be 1/2. If we have sine 30 degree, so sine 30 degree, that's equals to 1/2, or we could have sine 2 alpha equals to sine 150 degree. So 150 degree, that also corresponds to 1/2. So that means we have 2 alpha equals to 30 degree, or we could have 2 alpha equals to 150 degrees. So solving for alpha, so alpha comes out to be 15 degree, or we have alpha equals to 75 degree. So this is the direction. So we can say that the line, the straight line L, so here alpha could be either 15 degree, so there is also another possibility such that the lines still passes through 1, 2 and intersects x plus y equals to 4, and it's going to make an angle of 150 degree with the positive direction of x-axis. So let's note it down. We can say thus the straight line makes an angle of 15 degree, or it could make an angle of 75 degree with the positive direction of the x-axis. So that's our final answer.